Okay, so what we're going to be doing today is we're going to be learning about some properties of triangles. And I put a 1 on there because there's obviously a lot to talk about in triangles. It's one of the bigger things we talk about in geometry. Okay, the first thing we're going to talk about is some basic types of triangles. And these are types of triangles that you probably remember from pre-algebra, maybe some algebra class. First, we talk about the right triangle. If you don't remember, the rules for the stipulation for what makes a right triangle is this. It needs to be a triangle with one angle equal to 90 degrees, and that's exactly 1. It wouldn't really make sense for there to be more than 1 because that would already be 180, and you wouldn't have any left for the third one. But still the definition says 1 or exactly 1 angle equal to 90 degrees. The second kind of triangle is an acute triangle. And the reason we call it that is because all angles inside of it are less than 90 degrees. So every angle inside of it is an acute angle. It may also be an isosceles. It may also be equilateral. However, acute simply means less than 90 for each angle. And so it could be any combination that makes 180 altogether. And the third kind is an obtuse triangle. And of course, you can't have more than one that's bigger than 90, or again, we'd be over 180. So the definition is it has one angle greater than 90 degrees. Okay, so the next thing we're going to do is we're going to talk about the parts of a triangle. And you're already thinking you probably know what the parts of a triangle are. But when I talk about here is I want to talk about specifically sides of a triangle, usually relative to an angle. So when we look at our triangle right here, the first thing we're going to do is we need to have an angle as a point of reference. As you probably remember, a triangle has 3 sides, but in addition to that, every triangle has 3 angles. And what we're going to do is we want to compare the sides to the angle that we're talking about. So let's look at an angle here. Okay, we'll look at that angle right there. Depending on which angle you pick, the sides can be called different things. And what we call them is one of 2 things. We call them either opposite side or adjacent. Okay, and we're going to put those words on the screen in a second. And remember, for the notes, whatever I'm putting on the screen that's not on your paper is what you want to add. So first thing, I like to imagine an arrow coming out from the angle. So shooting straight out from the angle. Okay, and that's the way I remember. Whichever side that hits, that is your opposite side, always. Okay, and that's to me the easiest way. You also could say the 2 sides that connect the angle are the adjacent, but I prefer to do that arrow thing because it's very visual for me. Either way is fine. So after you have your opposite, whatever 2 sides are left over, those are your adjacent sides. And again, adjacent means connected to, so as you can see, those 2 sides create the angle. Those are the sides adjacent to the angle. Those words adjacent and opposite are going to be very important as we continue on in the class. So what I want you guys to do real quick here is we're going to go ahead and we're going to try to do some on our own. So as you can see on your paper, you already have 3. I went ahead and put the angles on here, so you need to add those to your picture. What I want you to do is I want you to follow that process and label the opposite and adjacent sides. So what I'm going to have you do is pause the video. As soon as you finish labeling them all, go ahead and hit play and we'll check and see how you did. Okay, so we'll go ahead and start on the first one. If you follow that arrow out, that's going to be your opposite side, which means the other 2 are adjacent. Following the arrow out again, that becomes your opposite side, and the other 2 are your adjacent. And the last time, following your arrow out, those 2 are your opposite, and that one is your opposite, and the other 2 are your adjacent. Okay, so it's as simple as that. Anytime you have a triangle, if they give you an angle, you should be able to think about opposite sides and adjacent sides and use that as a vocabulary word when we discuss sides of a triangle. And this is necessary because if you want to talk about a side, how do you know the name of it? Unless you have letters on there, how do you go ahead and call each one something? Well, speaking of letters, what I want you to do now is add those letters to the picture on your notes. Give you a couple seconds to do that. And feel free as well, since this is our first video, to pause anytime you need to add something to the picture, because I will keep moving, but I'm intending that you can pause your video. Okay, so now what I want you to do, just as practice of what we learned the other day, I want you to go ahead and using the notation, meaning using the line segment notation that we learned the other day, I want you to go ahead and list all the adjacent sides. So pause the video for a sec and just do that. Okay, so if you're confused on that, it's okay. What I mean by that is I want to list all the sides. So what they are are these right here. On the first one, okay, the side that's connected right there is TP. It's adjacent. So remember, we use that notation on top of it. A line on top of it signifies a line segment. And when we talk about sides, they're line segments because they don't go on forever. Okay, now, again, I want you to list all the opposite sides. So go ahead and do that really quickly here. Pause the video if you need to. All right, the opposite sides, there should only be 3 of them, are TE, YU, and AS. And again, if you switch the E and the T or the U and the Y or the A and the S, it's okay. Okay, next we're going to go ahead and talk about right triangles. They're very similar to the other triangles we worked on. The only difference here is that we have a right angle in there. And because of that, one side of a right triangle is always called the hypotenuse. Okay, so looking here, what I like to imagine is the hypotenuse is always opposite, so directly across from the 90-degree angle. Again, I use that arrow method, and so take your 90-degree angle, imagine an arrow coming straight out from it, and that part right there is your hypotenuse. And that's always the case. Now, because of that, we need a different angle to compare to. Otherwise, both the other two are adjacent. We don't have an opposite side. We don't have an adjacent side. All we have is a hypotenuse and 2 adjacent. So you usually then compare to a different angle. So for example, go ahead and mark that one on your paper. Now I want to know, okay, which one left is my opposite and which one left is my adjacent. So just like we did before, we're going to shoot an arrow straight out from there, and that makes my opposite side, and whatever's left over is my adjacent. And this is something we're going to use a lot later in the year in trigonometry. So again, I want to make sure you practice it and understand. On a right triangle, one of those adjacent sides is specifically called a hypotenuse. So it's just like a special adjacent side. So here's some for you to practice again. The paper already has them on there. Go ahead and label the angles that I placed on there. And I want you to label the hypotenuse, the opposite, and adjacent sides. So pause the video and do that. Okay, so again, starting off here, that's my opposite side, the adjacent side is there, and straight across is the hypotenuse. You could start off by labeling the hypotenuse, but I think if you kind of just shoot an arrow straight out, imagine the arrow coming straight out or draw it on your paper, then you'll see easily which the hypotenuse is. On the second one, same thing, shooting it straight out, that's my opposite, and then the hypotenuse is directly opposite the 90-degree angle. And the last one, my arrow went backwards. That's opposite, the hypotenuse is across, and adjacent is connected. Alright, so for this, and that's all for really the notes part of it, what I need you guys to do here is I need you to have a ruler that has centimeters on it and a protractor. And what I'm going to ask you guys to do is just create some triangles. I'm only going to give you 2 pieces of information, so you can use those 2 pieces of information however you want. One of the things in geometry that's important is you follow exactly what I say. Now, if I were to give you more information, you would need to use it. However, all you have to do is follow the information given. And with that, you may create a lot of different triangles within your group. The idea is to develop a system to know what are the things that I can know for a triangle that for sure me and my neighbor will have to draw the same one. So we're going to slowly but surely get there and develop these rules on our own. But for now, it's just about building some triangles. So the first one I want you to do is build a triangle with a side of 5 centimeters and at least one 40-degree angle. I gave you some space in the notes. However, if you end up not having enough room, feel free to use a separate piece of paper. I believe the numbers are small enough that it should work out fine though. Okay, so when I ask you for this, just because it's the first one, I'm asking you to use a side that's 5 centimeters and a 40-degree angle however you want. It can be connected to that side, it could be opposite the side, but create a triangle that has a 40-degree angle and a side that's 5 centimeters. Second, I want you to build a triangle with at least one side of 3 centimeters and another side that is 4 centimeters. So they can be connected to each other. Well, they pretty much have to be connected to each other. You could also have an extra 3 centimeter side. That's why I say at least one or at least one 4 centimeter side as well. So you have to have one 3 and one 4. I don't care what the other side is. The third one, I want you to build an isosceles triangle with at least one side that is 6 centimeters. If you don't remember what isosceles means, it means 2 of the sides are 6 centimeters. So you could have 6 and 6, or 6 could be the third one, and you could have 2 different numbers for your isosceles part. Number 4, I want you to build a triangle with an angle of 60 degrees adjacent to a side of 5 centimeters. What that means is 5 centimeters has to be one side of that angle. Number 5, I want you to build a triangle with an angle of 100 degrees opposite to a side of 8 centimeters, meaning the 8 centimeter side is not part of your angle. That one would be a little tricky to do, so you could start with the 8 centimeter side and then figure out how far you have to make the angle go out to make it work. Number 6, I want you to build a triangle with an angle of 25 degrees and another angle of 60 degrees. Okay, and that just means that basically I don't care about the lengths of the sides, just make two angles that make a triangle together with 25 and 60. Okay, and that's it for the notes. Down below the video, before you guys go ahead and do all of the practice 1 through 6 with your protractor and ruler, go ahead and take the quick survey down below. Just make sure that you pick the period 5, or whatever period you're in for geometry for future years, or and then just make sure you put your first and last name. After you do that, make sure you click the submit button, and I will get the information to know you did it, and I'll see you guys tomorrow.